Oh, it's not live cam. Hello, Gunika.
Yeah, we have
I think it's live. Yeah, got it. Yeah,
Are we live? Okay.
yeah, we are live. Yeah,
Hi everyone. So we are here with our first session, Introduction to Machine Learning and Fundamentals of Python, that will be taken by Chanukya Patnaik, who is the co-founder and a data scientist at DPhi, and he's also a CMO and data scientist at Complidata, a startup in Belgium. So this is basically a beginner focus session, and we hope you're all excited. Yeah. So transferring the control to Chanukya.
thanks. Thanks a lot, Gunika. I think Gunika has already done the introduction, so I'll skip that. And just to give you some context, right? This bootcamp is being done in collaboration with AI Engineering YouTube channel and DPhi, and everyone have the opportunity to attend it for free, and also will be conducting. I mean, we'll be giving away some assignments as well as some quizzes which you need to perform in the next few weeks. And upon successful completion, you'll be getting a certification from our end. So that's some context about the boot camp. And coming to the vision of DPhi, we started DPhi with a vision to build data culture and democratize data science learning. And I believe, I have already spoken about it during the kickoff event. So with that, I'll get started. So just to give you, I just wanted to give a heads up, since the session is aimed for beginners who wants to get started. I'll keep this session as intuitive as possible. While it will also cover some of the fundamental technical aspects, and also we will be going doing a code walkthrough of Python fundamentals as well. Okay, and we also believe in this teaching pedagogy where we try to explain the intuition behind algorithms or any logic before we dive deeper into the subject, because this way, the learner or anyone for that matter will have more context, or will have much more motivation by understanding the intuition, and then they will have enough motivation to get into the deeper technical aspects. And this has been practically proven, and also has worked for us in the last couple of boot camps. Okay, and also I'll want to make this session as interactive as possible. So if you have any questions, or if you have anything, you can feel free to ask me. I think someone is saying there is echo. Maybe yeah, Gunika, is everything fine? Or
Fine on my side. Yeah, two
yeah,
people are saying there's echo. I'll just confirm with everyone.
yeah, and also maybe if you could mute or something, maybe I can also try it out that way.
Yeah, I was muted. Was my audio coming?
Yeah, great. Perfect. So with that, probably we'll get started. And if there are any issues, probably Gunika or someone would respond to the thread anyway. Okay. So yeah, as I said, I want to make this session as interactive as possible. So feel free to respond to my questions or ask any questions that you may have, and we'll be happy to pick them up. Okay. And coming to the learning objectives of today's session, we'll be talking about machine learning and its use cases, and also we'll be talking about the types of machine learning, and we'll be also talking about some of the ML keywords and Python fundamentals, which will be a hands-on session. First and foremost, as a data scientist or a ML engineer, the most important thing is to understand the problem or the business need and its underlying concepts and context. Okay, this is one of the first thing that we as data scientists or machine learning engineers should understand. And let me confess, data science or machine learning is not about the frameworks like Python or R, or maybe about SQL or a bunch of other things. It's all about problem solving. It's about solving a particular problem using data in a scientific way. So don't get carried away with the packages, or with the programming languages and all. Try to understand the concepts, and then I think in the process, if you have to invent new tools, you should be able to do that and solve the problems. It's all about problem solving. Okay. So with that, probably we'll talk about what is machine learning, right? So machine learning is nothing but you'll be giving some inputs to the machine, let's say some data points, and ask, and then basically you expect it to return some desired results. in a nutshell, it's an approach to making lots of small decisions using examples or data. So we'll try and understand this with an example. Okay, so we have a nice example here. Let's imagine you are a data scientist who's working at let's say Microsoft or Google, where you are handling the Gmail or Outlook section of it. I mean, like, where you are, and you are given this problem statement where you will have to classify an incoming email into spam box or inbox. Okay, so if you are given this problem statement, the first thing that you need to do is probably you need to collect a lot of data points underlying this particular problem statement, that is incoming emails, right? Now, so what you will go ahead and do is, first thing is, like, you will try and collect all the data points. The data points can be let's say sender email address, ID, subject of the email, email body, and so on and so forth. So how do I know that? Let's look at my email, right? If I look at my email, and if I go to any particular let's say email, so first and foremost thing that I see here is, I'll see there is sender name, and then I see the subject of the email, and then when I open it, I see the sender info, right? I see the email address of the person, and then I also see the uh, complete contents of the email. So this is what I see. These are the minute data points that you as a data scientist must collect once you identify the problem. The problem here is to, basically the problem that we need to solve is to classify a particular email, incoming email, into spam box or inbox. Okay, and the first thing that we would probably do is to understand the problem, which we already did, and the second thing is we need to collect the data. So that's what we are doing. We will try and collect all these data points, and then we go ahead and experiment with our problem, right? So what happens is we try to put, or like, we try to feed in all these data points into our magical box, which is nothing but a machine learning algorithm, and expect it to classify it for us, whether the email should be going into inbox or spam box. Okay, so this is what typically we expect out of a machine learning process or a machine learning algorithm. Okay, so if we have to look at it in a real time, right? So for example, this is how the data might look like. Okay, let's say, okay, sorry. Here, as you can see, the data can be in this form, where there is a sender name, sender email, subject, body, and classification. Classification is nothing but, like, here I have considered three classifications, that is primary, promotions, and spam, as I have it in my email address. Okay, I'm sure, like, you might have seen it on your emails too. There are typically 3 or 4 categories that emails get categorized into. So these are some of the data points. Now what you do is you feed in all these data points to the machine learning algorithm, and you expect it to produce the final classification. In real time, basically, you will end up getting all these data points, and what you expect your machine learning model to do is, so it sees the sender name, sender email, subject, body, and then it tries to classify, okay, it should be put in spam. Okay, if there is some discount keyword or whatever it is, get a discount, then probably it should be categorized into promotions.
Hi, Chanukya.
Yeah.
Can you please zoom in a bit?
Yeah, sure. Yeah. So yeah, basically, like, these are the data points that you might end up getting on a real world basis, where, like, as a incoming email might have a sender name, a sender email address, subject, and the body. Okay, if this is the particular thing, then probably, like, you would classify it as primary or whatever it is. The machine learning, you expect the machine learning model to classify this for you, because you as a human being can't categorize each and every email, right? So you want to automate it. So that's where we use machine learning to classify these things. So this is one sample use case where, like, we know, like, what is a machine learning model and how it works in a real world setup, right? And coming to how, so we understood what it is and why it is used. One is, like, when it comes to what, we already know what it is, and why it helps in automating things, it helps in personalization, and it has a lot more use cases. We will talk about it in a while. Okay, and coming to how, right? How is the entire process defined? the first and foremost thing is we need to identify the objective, or we need to define the problem statement very clearly. And then we should go ahead and put forward our data requirements or start collecting our data. So in this case, the objective is to classify the emails into spam or inbox. And coming to the data requirements, you'll end up giving a ton of data requirements. Let's say sender name, sender email address, at what time the email is coming. And it can be anything else. I mean, anything that is related to incoming emails. Okay. And you start collecting the data. And then you do something called as EDA and data pre-processing. Okay, so that's something that we will be covering in the next few sessions. And then we do the modeling, and basically we apply the machine learning models in this step. And then we do the evaluation part, where we try to evaluate whether a particular model is working properly or not. Okay, obviously, like, once after we build it, we need to evaluate whether it is working or not, right? So let's take an example of our exams. Okay, first thing that we would do is probably we end up learning and preparing for the exams, but somewhere, like, there will be, like, we will be graded, right? After writing the exam, we'll be graded. Similarly, like, we need to grade our machine learning algorithms in order to evaluate them, whether they are performing well or not. Okay, so we'll also be talking extensively about this in the next set of sessions. And once we evaluate and once we identify that, okay, this is the best model, then we go ahead and deploy it. Okay, and then we keep monitoring it. And if we have to make any changes, we again, like, follow the same, follow this cyclic process here, and then make changes. Okay, this is how a typical data science process or a machine learning pipeline looks like. We will also talk about it extensively in a while. Okay, and coming to some of the use cases, right? So one thing is, I think this is one of the widely spoken thing, fraud detection. Okay, I'm sure, like, pretty much most of you must have heard about credit cards. Okay, and you might also heard, like, you might also heard about credit card fraud as well. So basically what's happening is, you might have a credit card and there might be some hacker who is using your credit card and then purchasing something else for them. Okay, and then in a way, like, you're losing out on that money, right? So banks are facing a very, very big issue with that. So what they started doing is they started capturing a lot of data points around credit card transactions. So a typical credit card transaction can have, what are the data points that a typical credit card transaction can have? One is, who is the owner of the credit card? Okay, which location they are in, which city they are in. I mean, basically the demographics. Okay, and also what are they purchasing? In the sense, like, the bank will also know, I mean, like, if they are purchasing something on Amazon, or if they are purchasing offline in a, let's say, grocery or a supermarket or whatever it is. So the bank will also know that, right? So these are some of the bunch of data points that bank collects, and then it detects whether a particular transaction is fraudulent or not. So in a way, bank can, if the bank identifies that a particular transaction is fraudulent, then they can technically stop it from being like, accepted, or like, being transferred. Okay, so they can technically stop that transaction if they identify that it's a fraudulent one. And it's happening right now. I mean, there are some of the neo banks like Revolut and bunch of other banks. They are actually using these fraud detection algorithms to be able to stop certain transactions if they find that there is some suspicious activity in the transaction. So a quick example, right? So let's say, like, I have my credit card in India, and when I'm making a transaction somewhere abroad from Belgium, okay, my Indian bank account can technically think that, okay, I mean, this person belongs to India, whereas he's making a transaction from Belgium. That too, he's making a transaction to some other, let's say, like, if I'm buying some products on Amazon.com, or maybe Amazon Germany or somewhere, then like, let's say my Indian bank can think that maybe, like, I'm not using the credit card, probably someone else might be using it. Okay, I gave a very small example, but there can be very much more complex cases. Okay, which like, machine learning algorithms are very adept at identifying, okay, these anomaly detections, and then report it to the bank. Okay, so that way, a lot of things will be optimized in terms of fraud detection. And coming to email spam filtering, I think we already spoke about it, where machine learning algorithms technically help email clients to categorize emails efficiently. Okay, you don't necessarily need to do the manual work. The machine learning models will do that for you. And similarly, it can also help you in product recommendations. Let's say if you're talking about Amazon.com, let's say if you're planning to purchase a laptop, okay, and you might have searched for some XYZ laptop today, and tomorrow when you open Amazon.com again, it will end up showing some really nice product recommendation saying that, hey, why don't you buy this laptop, or this laptop has a very cheaper price, or whatever it is. It also helps in another thing where machine learning algorithms are used is targeted advertising. Okay, even there, it is extensively used. But yeah, that's some context about where machine learning algorithms are used. And also have some nice slides over here, wherein it was prepared by Learn Machine Learning. Before that, let me just check if there are any questions out there on live chat. I don't see any questions, but yeah. And coming to this thing, right? How Google is using machine learning. Let me showcase it to you. Okay. So one of the things is, as I said, it is used for categorization. That's one of the biggest use case. And it is also used for searching. I mean, it predicts what you're searching. Let's say, if we want to, let's say, nearby pharmacy. Okay, if I'm typing nearby, then it is showing nearby pharmacy or post office or whatever it is. This is the prediction that Google is doing. So even here, Google is using some predictive algorithms in order to do that. Okay, and basically it's anticipating what we are looking for. Similarly, it is used in Google Maps to get real-time data of bus location and forecasts in real time, right? Okay, this is the tentative time you would be reaching a particular location. Okay, it's extensively used in Google Maps. And there is another use case where it is extensively used in Google Assistant as well, where it will yeah, so that's where it uses machine learning. Okay, where it will be using NLP and others. And coming to translations, okay, translations is again a big use case where NLP algorithms are used to be able to translate content from one language to other language. So that is one of the biggest use cases as well. And even in Google Photos, it actually, I don't know if you have seen this feature or not, it also detects the pictures. I mean, it also detects your picture, and it can technically categorize all your pictures that you have taken in the last 1 year or so far. Okay, so it can easily do that categorization based on the face recognition and a bunch of other things. Okay, and again, there is something called as deep dream. Even this thing, I haven't explored, but that's where Google is also using. These are some of the very basic ones where Google is using. Similarly, if we look at Facebook, okay, Facebook is using it for face recognition. So for example, whenever you upload an image, it ends up showing, okay, this particular image, this particular person in this image could be your XYZ friend, or some other friend, and it automatically detects, right? That's where it uses facial recognition algorithms. Especially it uses deep learning there. And also it does textual analysis. Okay, you might have probably you might have posted something, let's say about your you wanted to buy some product and you are asking for recommendations. Okay, let's say you have made a post on your Facebook wall, and then automatically it does that textual analysis, and they can technically target an ad based on what recommendation that you are looking for. Let's say you are looking for a iPhone or a phone. Okay, probably Facebook can technically, I mean, has that capability to show you ads related to phones. Okay, that's a very sample case I'm just giving, but there can be a lot more too. I'm sure, like, you must have noticed this while using Facebook. Okay. Again, targeted advertising. Okay, this is again, like, it depends on your basically it tries to observe your activity on Facebook, your interests, and based on your interests and based on your activities on Facebook, they also do some targeted advertising by using machine learning algorithms. Okay, so this is something. And language translation. Facebook uses its own language translation engine. They have built something new recently also. They have exposed they have released some of their research findings as well. So it is also used in language translation. And what are the different newsfeed items that needs to be shown on your Facebook wall, right? This is also, like, even in this machine learning is used. So these are some of the use cases that Facebook, where, like, Facebook is extensively using machine learning. And these references were taken from Learn Machine Learning. Thanks to them, they keep posting that resourceful information. Okay. And if any one of you knows any other use cases, feel free to put it. And also I'll probably read some chats here. How to get started in machine learning. Text to speech is one more NLP use case Google provides. Yes, Mahesh, you're right. And yeah, so that's some context about some of the use cases that we have done. And coming to, like, someone asked what are the use cases we are going to handle in the bootcamp. Yeah, we will probably be working on some of the use cases. Just to give you some context, in the previous bootcamp we have worked on let's say animal detection, and also in some of our datatons we also worked on X-ray image data sets and bunch of others. But in this bootcamp we will probably be working on some classic machine learning problems, where, let's say, we would focus on problems like loan prediction and things like that. Okay, which are very classic in nature. Okay, so we will get back to you on that. Okay, we won't be working on deep learning or NLP in this bootcamp, so that is slightly beyond the scope. But we definitely have resources and material in the previous bootcamp if someone wants to refer to it. Okay, so with that, let's try and understand some keywords before trying to understand what are the different types of machine learning algorithms that we have. So first and foremost thing that we need to know is whenever we are talking about machine learning, supervised machine learning, which I'll talk about in the later stage, we talk about something called as target or label, which is which is of prime interest to us, which we would want to predict. Let's say in the case of email classifier, right? There can be a particular label called as email classifier or category of the email. So that can be the label. Okay, let's look at the label in our data set. Okay, what it is? It's classification. This is called as a label or target, because this is what you would want to predict at the end of the day, right? So yeah, this is what you would want to predict at the end of the day. And the remaining variables that you see here, remaining column names, sender name, sender email, subject, body, these are nothing but called as variables. Okay, so that's some context about what is a target and what are variables. Okay, or input variables, features. Okay, they have different names. Don't get carried away with that. Again, it's just jargons. We end up using multiple names for the same thing, which also sometimes confuses, but let's keep it very simple. So there is something called as label or target, which is our output variable. And there are something called as variables or input variables, features, which are the remaining data points which we would feed in to the machine learning algorithm to be able to get desired results. Okay, so yeah, that's some. And let's take another example of a standard metropolitan areas data set, where we will have to predict the crime rate. Okay, before discussing that, I'll probably discuss a little more about the data set. So we have a data set which has 99 standard metropolitan areas in the US. Okay, and the data set provides information on 11 variables. Okay, and the areas are divided into 4 geographic regions: northeast, north central, south, and west. The variables are as follows: it has land area, percentage city, percentage senior, physicians, hospital beds, graduates, workforce, income, crime rate, region. So these are different variables that we have, and our objective in this particular data set is to predict the crime rate. Okay, that is nothing but this thing. Okay, this particular variable. So that becomes our target, and the remaining variables that we have in the data set becomes our features. Okay, let's look at it here. Okay, this is our data set where we have all 11 variables, and crime rate will be our target variable, whereas the remaining variables that you see here will be your input features or features. Okay, input variables or whatever it is. Okay, and what you technically do is, when you end up when you want to build a machine learning model, right, you take this data. This is nothing but the historic data, which are nothing but examples. You give a lot of examples to your machine learning model, and you expect it to function very well in the real time. Okay, whenever it sees new examples in the real time, in near future or in future, so you expect it to follow the examples that it has learned in the past, and then produce the results based on the examples it has learned. So for example, let's take an example, right? When we are kids, we are taught, okay, we are shown a dog, and we are taught that, okay, this is a dog. We are shown a cat, and we are taught that, like, this is a cat. Okay, as a kid. And probably as a kid, like, we might end up after 10-15 days, when we are asked, when we are shown a cat and dog, and when we are asked to classify whether it is a dog or cat, okay, we may end up getting it wrong, right? Because we were introduced to that weather for the very first time. So similarly, like, machine learning algorithms can also go wrong. So it's not 100% accurate always. So yeah, so similarly, like, they end up learning with examples, and then they are expected to do well in the real world scenario as well. So in this particular case, in a real time setup, right, you end up getting all these data points. Okay, all these data points, which are nothing but your input features, and your machine learning algorithm should predict the target, that is nothing but the crime rate. Okay, and crime rate can be 60%, 43%, or whatever it is. It can be some point. So this is what you are expected to do. As I mean, this is what your machine learning algorithm is expected to do at the end of the day. Okay, right now I'm manually inputting the values, but we can't do it for, let's say, millions of data points, right? At that time, we use machine learning algorithms to efficiently predict this for us. Okay, so this is some context about what are target variables and what is a feature. And coming to types of machine learning, right? So typically there are 3 types. Okay, one is supervised, unsupervised, and reinforcement. Okay, in this bootcamp we will be talking about supervised machine learning algorithms only, and that too, like, classical. We'll be dealing with some classical problems, and just give me 1 second. Yeah. Yeah. So again, like, don't get overwhelmed with this particular chat. So basically, machine learning algorithms are classified into supervised, unsupervised, and reinforcement learning. Okay. And supervised machine learning algorithms are the most, I mean, like, they are the most common sub branch of machine learning as of today. And typically, new machine learning practitioners will begin their journey with supervised machine learning algorithms. Okay, as the name itself suggests, that supervised machine learning algorithms are designed to learn by example under supervision. Okay, we give examples to the algorithm, and it learns from it, and it tries to predict. Okay, and we have a clear target variable when it comes to supervised machine learning. Okay, so this is something that we need to be clear about. When it comes to supervised machine learning, there is a clear target variable which we would want to predict. Whereas coming to unsupervised machine learning problems, we don't have any target. Okay, there is no fundamental called as target there. We try to find some interesting hidden patterns in the data set. Okay, so that's what we do when it comes to unsupervised machine learning algorithms. And coming to reinforcement machine learning, reinforcement learning, what happens is it learns from the interaction within its environment. Okay, it basically enables an agent to learn in an interactive environment by hit and trial process, and it gets its own feedbacks for its actions and experiences, and in the process it tries to learn. Okay, that's what a reinforcement learning type of an algorithm does. Okay, so let's look at it. Okay, we have spoken a bit more about supervised, unsupervised, and reinforcement learning in the next few slides. Okay, here there is a clear target variable. In the case of supervised machine learning algorithm, you have to predict the target variable. That's pretty clear. And coming to unsupervised, there is no target variable. Okay, however, like you try to find some interesting patterns. Let's say, like interesting, like let's say something called as you try to find a group of people in a data who are doing some interesting activity. Okay, so those are the kind of anomalies or like different patterns that you would observe by using unsupervised learning. And coming to reinforcement learning, as I said, like it is basically it learns through a hit and trial where it learns from the environment, and it might end up getting some positive or negative feedback, and over the time, like it tries to learn, and it's typically used in gaming and others. I mean, in gaming it has a lot of applications. So this is what it is in to summarize. Here, like you'll be in the supervised machine learning, you will predict. Okay, you'll be doing some predictive modeling where you will predict what is the next value. Let's say, like in the case of email data set, right, we are trying to predict, or like we are trying to classify whether this email would land in primary, spam, or promotions. Similarly, like in the case of standard metropolitan data set, we are trying to predict the crime rate. So this is a typical supervised machine learning algorithm. Whereas in the case of unsupervised unsupervised learning, you try to identify some interesting patterns, let's say anomalies or anything of that sort. Okay, you try to identify some clusters of data. And reinforcement learning, it learns from the mistakes. So we won't go deeper into this at the moment because it's slightly beyond the reach of this session. And it's fine if you don't understand this nuances at the moment. You will get to them as we as we get along. Okay, and then in the next few days, like we'll extensively talk about this, so you will hear the same keywords again and again, and when you hear it the second time or the third time, you try to understand them well. Okay, now let's quickly try and understand more about the supervised machine learning. Okay, coming to supervised machine learning, right, there are two types of problems that we deal with. One is regression, and the other thing is classification. Okay, before discussing about this, let me just check if we have any questions. No. Yeah. Yeah. So yeah, coming to the types of problems that we see in supervised learning, right? So there are typically two problems that we would be dealing with. One is regression, and the other thing is classification. Okay, in the case of regression, the outcome or the target variable is continuous. For example, here we have taken two examples. What will be the temperature tomorrow? Okay, we have to tell it in numeric number, right? And in the digits, let's say it would be 32 degrees Fahrenheit or 84 degrees, sorry, 32 degrees centigrade or 84 degrees Fahrenheit, or whatever it is. Like, we give a absolute number. Whereas if we say that, will it be cold or hot tomorrow? Okay, here we are trying to classify the target variable, whether it would be cold or hot tomorrow. So that is nothing but a classification problem. Okay, so these are typical regression and classification problems that we will be dealing in the next few weeks. And here are some typical examples. Okay, if I have to talk about classifying the outcome, right? When it comes to classification algorithms, predicting whether a transaction is fraud or not. When it comes to credit card transaction data set, we will be predicting whether a particular transaction is fraud or not. It's a pure classification problem. We are saying yes or no, and predicting whether we need to give loan to a particular person or not, given a bunch of data points about that particular person. Okay, let's say age, gender, and probably geography, and their salary, and bunch of other things. We will end up taking a lot of data points and try to predict whether we should give a loan to that particular person or not. Okay, so it's a yes or no. And predict whether to give college admission or not. Okay, that is another example. Predict the grade. Okay, if let's say, like, we are in universities and colleges, we end up seeing these grades, right? It will be given A grade, B grade, C grade, D grade. So you will be classified into different grades based on your performance in the test. So this is a multi-classification problem. This is called as multi-classification, where there are more than two classes. It's not just 0 or 1. It's not just yes or no. There are more than two classes, and that's why it is called as multi-classification. And that's some context about the classification problems. And coming to regression problems, right? Here the outcome of the variable will be continuous. Let's say predicting the house price or predicting the crime rate. So we just spoke about the example of standard metropolitan areas data set, where we are trying to predict the crime rate, right? Which is an absolute number or a percentage. Okay, so this is a continuous value. So this is the regression problem. Whereas coming to email dataset, it's a classification problem. It's a classification problem, because we are trying to classify whether a particular email is spam, promotions, or primary. Okay, so that's some context about supervised learning, and yeah. Yeah, and I'll probably give some more examples in here. Okay, based on the student profile, you can predict whether a particular student will pass or fail. This is a classification problem. Whereas based on the student profile, you can predict the student marks. When I say student profile, it will be like you'll be capturing the data points of each and every subject score and bunch of other things. So we'll be talking about a lot of data points. When I say student profile, it's not just the name, it's not just about the name, gender, or bunch of other things. It's also about which class they are in, and, like, what is their performance in uh, each of the courses, so that allows us to predict the percentage. Similarly, pass or fail. If it is pass or fail, then it's a classification problem. If it is a percentage, then it is a regression problem. Okay, again, like, this is a workflow which we have already discussed. This is a standard workflow for a typical supervised machine learning algorithm. First and foremost is we need to identify the objective or the problem statement, and then we need to collect the data. Okay, we need to collect the data from the data sets, and then we will be doing the data preparation. Okay, the data preparation will involve a bunch of things. Let's say, for example, you will have to clean the data. Okay, and also there might be some missingness as well. Probably let me just show you how it looks like. Okay, and yeah, so let's take an example of which country are you from. Okay, if I give a question, which country are you from, someone might say that I'm from US or USA or United States of America, or whatever it is. Like, different people can write it differently, right? So this way, like, the data is much more messy. When you're asked this question, which country are you from, and it is a free field text. Okay, you are given a very free field text. It's not an option where you can select from a set of options, but you are asked to give a like, let's say, like, you're asked to fill it in general. Let's say, like, let me just take an example of yeah. Let's imagine, like, you're not given a list of fields, but you're just given this type of field where you need to enter what is your country name, and you're not given a drop down where you can select one. In that case, probably individual A might write it as US, individual B might write it as USA, individual C might write it as United States of America. And this way, like, when you end up getting all these data points on your database, it becomes very junky, and also you have to clean all these things, right? You have to collate and you have to say that, okay, all these are actually US. In the first place, we shouldn't have done that mistake of giving a free field text. We would have rather given a drop down and asked them to choose the country of their choice. Okay, so these are some basic mistakes that a lot of organizations might have done in the past, and they are correcting it now. And in fact, like, I have seen some of the big organizations also do these simple basic errors. And similarly, like, in order to clean up that mess, right, you need to prepare your data by cleaning that data, as well as you have to do some data pre-processing. Or if there are, and some people, if it is not a required field, right, some people may not fill that value. Okay, in that case, you will also have a lot of messiness too. Okay, so a lot of values will be missing. So let's say, like, what is your country field is not a required field. In that case, like, a particular person might write it, might enter their country name, and some other people may not write it because they are not interested to give more data to an organization, right? So in that case, like, we should definitely take those things into consideration, and also we need to fill those missingness, or, like, we need to solve that missingness, diagnose it, and then we have to do the modeling. Okay, so this data preparation is one of the most important things, or, like, where data scientists end up spending more than, like, let's say 70 to 80% of their time, because the real world data set that we see usually in industries is a lot more junky and a lot more dirty, and it's not very glamorous. So you end up spending a lot of time here. So this is one of the critical steps. And after doing this, you end up modeling, and then that's where you use some machine learning models. And then after doing applying these machine learning models, you try to evaluate them, you try to grade and see whether they are performing well or not. And if you are satisfied, you reiterate this process, and if you're satisfied with that, that's when you deploy it in the real world, and then try to monitor it. So this is a typical workflow that typically, like, everyone would follow. I wrote the same thing here. Okay, but yeah, that's some context about this. And probably, like, I'll open my Jupyter notebook so that we can do the hands-on session. Just give me one second. Yeah. Yeah, with that, probably, like, we'll get started with Python fundamentals. Okay, we'll be talking about some of the Python fundamentals, and how we can effectively use Python in the machine learning. Again, like, before I kickstart with this second half, I just want to clarify that machine learning or data science is not about Python or R or any particular programming language. It's all about yeah, it's all about just give me one second. Yeah, I think we lost Gunika. I'm just trying to have her back. Yeah. Okay, cool. So we can probably get started. So before we get started, right, I just wanted to clear off this thing that Python is, data science or machine learning is not just about Python or any other framework that you might have heard about, let's say R or TensorFlow, or maybe PyTorch or a bunch of other things. It's not about that. It's about using data effectively and it's all about solving a problem by using data effectively in a scientific way. That's what it is all about. Okay. And with that, let me take you through some of the Python fundamentals. Okay. For those unattended, there is something called as Google Colab, okay, which we will be using. And there is also something called as Jupyter Notebooks. But today, in this session, we'll be using Google Colab. Okay, anyone, what does this Google Colab do? It provides you with a interface where you can run your Python scripts. Okay, and you don't really need to worry about installing Anaconda or some other softwares in your machine. You can simply run your Python scripts online in a matter of few seconds. So just search for Google Colab on Google, and then open this. All you need to have is a Google account, Gmail account. That's it. And you create a new notebook and you're there. Okay. Your online Python environment will be created. And it's pretty seamless, pretty easy to install. When I started learning coding, I had to install, I had to install some IDE and then, start with coding. Whereas when it comes to data science and machine learning, I think you can seamlessly use these online notebooks like Google Colab, or you can also use something called as Jupyter Notebook. Okay, there are Azure notebooks too, but I think Google Colab is pretty easy to get and follow. Okay, so this is how you can create your notebook and you can run your code. Okay, we have already written a piece of code here, so we'll probably use that. Okay, so first and foremost thing is actually, yeah, I can zoom in. Great. Yeah. Yeah. So the first and foremost thing that we will be talking about is input and output functions, and then we will go over variables and data types, and then we will talk about some of the basic operators, data structures, and few others. Okay. And also we'll go through Pandas library as well. So that's we will do it very quickly. And coming to input and output functions, right? So this is one of the standard thing that probably everyone would have told whenever you start. Whenever you install your environment, a Python environment or any other coding environment, you try to type something called as hello world. Okay, in order to write that particular code, you can click on this code element which is there out here. Okay, you can use this function called as print. Okay, print and say it as hello world. Okay, probably this way we can write our very first program in Python, and all you need to do is do control enter, or you can click on this so that this particular program can run. Okay, so basically what does this print function do? It basically instructs us to instructs to print something that is inside the parentheses. Okay, so similarly I have written another piece of code which prints welcome to DPhi Machine Learning Bootcamp. Okay, and what are these functions in the first place? Okay, functions are basically, they are, you can reuse a particular code. So for example, sometimes you end up writing a piece of code. However, you and coming to that piece of code, right, you might want to reuse it again and again. Okay, at several instances where you have multiple use cases. So in that case, what you do is, instead of writing that piece of code again and again, what you do is you write a function for it. Okay, and then you reuse it whenever you want to. It's similar to what we might have learned in our 5th grade or 6th grade about functions, right? You give some value to functions and you can reuse that function anywhere. Let's say f of x is equals to x square, and when you input f of phi, then it throws phi square, that is 25. Okay, similarly, what you will do is, let's say here we have an inbuilt function called as print. Okay, so whenever you want to print a statement, you just simply use this function print and you print it. Similarly, there is some other function called as input, okay, which allows you to ask a question. Let's see how it works. Okay, So here, we have asked which track are you enrolled in the bootcamp. Instead of age, probably I'll write track. Okay. Here it is asking which track are you enrolled. Let's say if I have enrolled into advanced, then I'll type advanced and then click on enter. Okay. And if I want to print the track, I'll just type print track. Yeah. And when I print this particular variable track, then I'm getting advanced. Okay. So this is some context about input and print functions. Okay. So you can technically use input for anything. I mean, let's say if you want to ask what is the age, right? Let's say what is the age of, what is your age? Okay. You just need to put it in parentheses. What is your age? And you just need to do control enter and put your age, and it will show you that value. So this is how our input function is used. And coming to variables and data types, right? Yeah. So basically, variable is nothing but it's considered as a storage container for data. Okay. So if let's say you throw a value, let's say here we have used a particular variable called as a, and we are storing a value called as phi. Okay. So this is nothing but we are basically storing phi in this particular variable called as a. That's it. Okay. Variables are used to typically store data, and creating variables in Python is very simple. As I showed you, you're here storing phi in a, and you just click on run, and you'll be able to, you are basically capturing phi in a. Similarly, if you want to see what is in a, right, what you have to do is you can use print function and a and see what's there inside a. That is nothing but phi. As you can see it here, you can see what is there inside a. Okay. So it's typically variables are used to store data. Okay. And this is how you can create variables, and every variable will have a name. Okay. And it's always good to store information while making it easy to refer again, right? So it's always easy, good to create these variables where you can store this information, and also to understand what type of what data type they have. What we need to use is we need to use another inbuilt function called as type of a. Okay. Before even talking about this type function, let's understand what are the data types. Okay. So in order to explain the data types, I'll probably give a nice analogy. Let's say a particular learner. Okay. Let's say John is attending the session. Okay. Attending today's session. And the first and foremost thing is, let's capture some data points of John, right? Okay. John is his name, and his age is probably 28, and he is from, let's say, the city called as Leuven, and he is attending the session at 4 p.m. in Leuven. Okay. So these are nothing but data. This is nothing but the data points that you're capturing of a learner who is attending this particular session on Introduction to Machine Learning, right? So in this particular case, there are different data points that we are seeing. One is John, which is nothing but it has a bunch of characters, which typically in programming languages called as strings. Okay. And there is something called as 28, which is the age of John, which is nothing but an integer. Okay. And again, coming to Leuven, it's again characters. It's called a string, and 4 p.m. is time. And let's say if we are capturing the data as well, let's say it's 2nd December 2020. Okay, so this is nothing but a date. The type is a date. So similarly, there are different data types that you might encounter. One is integers, strings, booleans, and bunch of other things, okay, which we have discussed in some of the courses which we have already shared with you. Here I'm just taking you through these things so that you are familiar with them again. And coming to the strings, right, it is nothing but sequence of characters, as we already discussed. Let's say we are creating a variable name. with DPhi. And whenever you are creating a variable with string, you always need to keep it in parentheses. So here we have created a variable called as name, which has DPhi in it. And in case if you want to access some of the elements within that string, let's say you want to access a D or P or H or I, then what you need to do is you need to basically in Python, right? The elementing or the indexing starts from 0. Okay, when you call 0, then it gives the first element. Similarly, when you want to get P, right, instead of giving it as accessing it as element 2, what you need to do is you need to access it as element 1. That's when you end up getting P. So let's see how to access D in the above variable name. Okay, so if we use this function print name 0, we'll be able to get D. Similarly, we can get H by using 2. Okay, why are we getting H here when we are using 2? Basically, D is considered as basically the index of D is 0 and the index of P is 1 and index of H is 2. That's why we are getting H here. Okay, similarly, if you want to get the character length, right, you use some function called as inbuilt function called as len, len, and you give the name of the variable. Okay, so these are some of the basic inbuilt functions that you can use to be able to get it. And again, here we are capturing something called as gender as male. And when we are trying to check what is the type of this variable called as gender, then we are getting it as okay. I'm getting this error because I haven't defined what gender is. So I need to run gender first. And then when I check for the type of the gender, I can see that it's string. Okay. Similarly, yeah, coming to the next section, right, we will talk about comments. So basically, if you are writing a piece of code, okay, and you want some other people to also know what you are exactly writing, right, that's when it's always good to write some basically it's good to write some comments saying what you are exactly doing with that piece of code. Okay, so it's always good to give more context about your code so that anyone in this world can technically read your code and reuse it later if they want to, especially when it comes to industry, right? When you're working as a data scientist or when you're working as a software engineer at an organization, it's always they expect you to do some good enough documentation and commenting so that other people in the organization can also follow through in the future. Okay, so that's some context about comments. And also you might be wondering, how did I get these things, right, in between the notebook? In order to get that, what you need to do is you need to click on text element and you should be able to create them, okay, by using some of the options out here. Okay, and coming to the operators, right, operators are nothing but they're used to perform some operations on variables and values. Let's say additions, subtraction, multiplication. Okay, these are some of the arithmetic operators, and there can be some conditional statements too, which we will discuss later on. And I'll quickly, so coming to the one of the simplest arithmetic operators is addition, and I'll probably do 5 plus 5, which is 10. Okay, you just need to run this code. And similarly, you would want to, if you want to let's say multiply, you can say 5 into 5 and run this piece of code and you'll get 25. So these are some of the, you can also use Python for as a calculator too. Okay, so that's some context. And yeah, and coming to the data structures, right? So again, coming to data types and data structures, there is a confusion out there where it is sometimes in Python they are interchangeably used. And if you are learning Python from multiple sources, you might encounter these terms, data structures and data types, being used interchangeably. Coming to data structure, right? In general computer science concept sense, data structure is a data organization or management or storage format that enables programmers to efficiently access and modify data. Okay, that is what data structure is called as. It's mostly to do with organization, management, and storage of data. Okay, so that we can access and modify it seamlessly. Okay, and coming to the data type, it can be, as I already spoke about data types, right? We have data types which are integers, booleans, we have strings, and bunch of other things. So yeah. And with that, probably let's go over some data structures here. I have listed down lists, tuples, set, and dictionary. Okay, let's create a list. Okay, John, here we are creating a list of 5 different names. Okay, and in order to create a list, you just need to put them in square brackets and put each of the names in parentheses. Okay, this is how you create a list. L is equals to this thing. And if you want to access the list elements, right, you can do it the same way as you were accessing the strings. L of 0 will give you John because this is 0. In Python, the indexing always starts with 0. Okay. And if you want to access Gene, then it's 0, 1, 2, 3. That is L of 3. Okay, you'll be able to access Gene. And similarly, you can use this function called as length to able to get the length of the list. Okay, here there are 5 elements in the list, right? So that's why we are getting it as 5. Okay, and also you can use certain methods that would allow you to sort, filter, and index. Okay, I'll probably leave this for now, and we will quickly jump to libraries. Okay, so this is some very quick beginner level thing for those who are unattended and who don't know Python programming. I hope that helps them. And coming to the libraries, right? So we spoke about functions, we spoke about data structures, data types, and bunch of other things, operators and all. Coming to libraries, Python is, as I told, Python is one of the easiest languages, easiest programming languages, and anyone with limited to no knowledge about coding can easily start off with Python. As you can see, we can simply create our own environment and run all these particular pieces of code, right? So similarly, coming to libraries, what happened is a lot of open source contributors, they started contributing a lot of libraries to a Python. So they ended up writing a piece of code which is then converted into a library which can be reused by a lot of other people in the community too. So they made it very seamless so that everyone and anyone can technically use it. So for example, if I have to give you an analogy of a library, right? So let me just walk you through this. Yeah. So let's take an example of how do we procure tomatoes. Okay. One thing is either we farm and we try to do the entire farming and then produce tomatoes by extensively working on it. That is one way of doing it. And the other way of doing it is other way of procuring tomatoes is easiest way where we can simply go to a nearby grocery store and we get it. Okay, we get the tomatoes that we want. Okay, so similarly, when we use the same analogy for libraries, farming is like writing code from scratch. Okay, where you write each and every step from scratch and then you get the desired results. Whereas when it comes to using libraries, it's like you're going and buying from a nearby store or someone who has already done all the hard work and done all the groundwork and made it in such a shape that you can simply reuse those libraries by installing them. Okay, so what we do is in this particular case, what we will have to do is there are some really important libraries for machine learning and data science. They are NumPy, Pandas, Matplotlib, Seaborn, and all. So NumPy and Pandas, they are usually used for, Pandas is built on top of NumPy, and it's mainly used for data analysis, data cleaning, and a bunch of other things. And coming to Matplotlib and Seaborn, they are usually used for data visualization and others. Okay, so in order to import or in order to install a particular library, what you need to do is you need to type in something called as pip install Pandas. If you want to install something called as Pandas, then what you need to do is you need to type in this thing on by default these are already installed on Google Colab, but just in case if you want to install on a notebook or somewhere, you just need to run it. Okay, and then you'll be able to see that okay, this requirement is already satisfied, which means that Pandas is already there on this particular environment. And then what we do is we import Pandas as PD. Why are we even doing this? If I have to call Pandas again and again in my code at later stage, instead of writing Pandas, I can simply type in as PD. Okay, so that is a short form that we would use. Okay, you can, instead of using PD, you can also use P also. But again, you have to remember, and you also need to comment and tell your colleagues or whoever is referring to your code. Okay, so this is how we import Pandas as PD, where we can use PD short form in our code at a later stage. Yeah. Now coming to reading and viewing data, right? How do we access data sets? Okay, so this is one of the first things. So we have seen this email data set. Okay, how do we access this data set? Okay, so that's where we will be using Pandas. Okay, here I'm creating a I'm creating a data frame. Data is equals to, so in order to read the data set, right, read this particular CSV. So I have this data. I'll just show you how it looks like. Okay, this is the data set that we have. Okay, this is the data set that we are following right now. And in order to read this data, right, what we need to do is we need to use this simple function PD. PD is nothing but Pandas dot read underscore CSV. And we need to put this URL in the parenthesis and then run it. Okay, this way I'll be able to read my CSV. Okay, and then if I have to see the first few values, right, if I have to view the data, then what I need to do is I need to use this small method called as dot head. Okay, function. Okay, so I just need to declare this particular data set name, that is data dot head, which would allow me to see what is my data set is all about. Okay, my data set has age, gender, and bunch of other variables. Okay, as you can see. Okay, so this is something that is uploaded on GitHub. So throughout the bootcamp, we will be uploading data sets on GitHub. However, if you want to load some data set, right, let's say if you would want to load this data set, okay, I would download it in let's say CSV. And if I want to load that particular data set, what I'll do is, so it is downloaded here already. Okay, what I'll do is I'll just click on this and then upload this data. Okay, I'm just uploading this data. Okay, here it is already present. Okay, I can already see it here. I'll just copy the file path. And if I have to give it, right, so I'll just, instead of this URL, I'll just give that URL and run it. Okay, and also see what is there in my data set. As you can see, I can see the first 3 entries because the data set is not long, so I can't see first 5. So I can see sender name, email, and bunch of other things. So this is how you can read any CSV file using using Pandas. So I'll just undo this for now. Okay, I'll just read the previous file. So I'm just keeping the GitHub file itself. So when you use this particular when you use this particular method dot head, you'll end up getting the first 5 rows of your data. Okay, and if you want to know more information about your data set, right, you use something called as dot info. Okay, data dot info. Why data? Again, because that's the name that I have given here when I loaded or when I read the data. Okay, so you just run this particular data dot info, and you can see that age. Okay, the column 0 is age, and age has 583 non-null values, and the data type is integer. Gender has 583 non-null values, and it's an object, and total bilirubin is float. Okay, why is it float? Because it's in 0.7, it's in decimals, right? So that's why it's in float. Okay, you can learn more about floats, integers, and others in the reference material that we have shared. And so these are the observations that we can make out by seeing this information, right? One thing is there are 583 observation. observations in the data set, and there are 11 columns. How do we know there are 11 columns? It starts from 0 to 11. So that's how we know there are 11 columns in the data. And there are both numerical and categorical. I mean, there are basically floats, integers, which are numerics. And at the same time, we have seen some categorical data. Categorical data is nothing but let's say like, liver disease. Sorry. Yeah. Yeah, gender is a category where like gender, there are two categories, right? One is male, female, and probably there is others. So these are three categories, so it is called as categorical data, okay, which is the object. Okay, that's what we are able to infer from this particular information. There are 11 columns basically. As you can see, there are 11 columns, and there are I guess there are 583 observations, that is 583 rows. And if we want to check for missing values, right? I spoke about the missing values thing, where like some a particular user may not be filling their data or data points or whatever it is. Okay, in that case, like you end up getting a lot of missingness in your data set, right? So yeah, that's one thing that's there. So let me do a quick intro to this particular data set quickly, okay, for everyone. So the data set that we are referring to is a liver data set, okay, where ideally, like if we are solving this particular problem, the goal of this particular problem is to build a machine learning model to predict whether a patient has liver disease or not, given the set of data points. Okay, so what are the data points that we have? We have age of the patient, okay, we have gender of the patient, total bilirubin, and there are a bunch of other data points, total proteins, albumin, and there is a target variable that is nothing but liver disease, whether a particular person has liver disease or not. This is our target variable, okay. But right now we are not doing any machine learning modeling. We are just trying to analyze the data. We are trying to understand more about the data, okay. So in the process, probably like some of the patients records are missing. So in order to check what all records are missing, so we can do a simple, we can use this particular command, data.isNull.sum, which says how many missing values are there in each and every column. Okay, as you can see, all the columns have almost zero missingness except for this particular column, which is albumin and globulin ratio. Okay, so this particular column has 4 missing values. And when we see some missing values, right, either, I mean, there are different ways of treating it. One is we fill the missing values, or we remove the missing values, or we try to diagnose it in some way or the other. So in this particular case, we are trying to fill this missing values with average of that particular column. Okay, so what we are trying to do is like we are basically creating a copy of it. To create a copy of it, I'm just creating a new data set, data frame called as data1, and I'm making the copy of data which I have already created. Okay, so yeah, so that's some context. And now what I'm trying to do is I'm trying to fill the missing values with basically the average of that particular column. So let's look at it here. Here we know that like albumin and globulin ratio has 4 missing values. So what we are trying to do is we are trying to fill the missingness with the average value of this particular column. Okay, in order to do that, what we need to do is we need to first access this particular column. How do we access? We just call data, and we open the like square brackets and use that column name. And then the next thing that we need to do is we need to fill the missingness, that is fill any, that is nothing but missing values, with the mean of this particular column, right? Again, like we'll be using data of this particular column dot mean, and in place is equals to true. Wherever there is missingness, we will try to incorporate, I mean we will try to fill it with the mean. So after filling it, we can see that like here it's completely okay. Wait, let me run this code. Now I have run this command, and like when I again try to check if there are any null values in the process, I can see that all the columns has 0 null values now. Okay. And now if I want to remove or drop those missing values, okay, right now there are no missing values, so I can't really drop them. However, that's one of the reasons why we created another copy of the data, that is data one. If I want to remove those missing values, right? So what I will do is probably I can use this something called as data one dot drop na in place is equals to true. This will basically drop all the missing values. Okay, it's very simple. Okay. This way, all our missing values will be dropped. Okay, by just this simple line of command. Okay, and we can see that all our columns has 0 missingness is null dot sum. Okay. So similarly, if we want to see some descriptive statistics of our data, what we need to do is we need to use this command, the name of the data set dot describe. That would give us a bunch of nice, interesting statistics. That is the count, how many records are there, what is the average value of that particular column name, and what is the standard deviation, what is the minimum value, what is the maximum value, what are the different quartiles that we have. So we get these nice statistics which allows us to analyze the data a bit more. Okay, so we can also use this particular function for that. Okay, with that, and these are some basics of pandas, where you can comfortably read the data and also get to know some information around the data and bunch of other things. So coming to, we will also be doing a very brief plotting where we will do some very basic data analysis of scatter plot, histogram, box plots, and all. So yeah. Yeah. So the first and foremost is we'll be using the scatter plot. Okay, again, here we are using matplotlib library in order to use that library. Okay, if you don't have the library, first thing that you need to do is pip install, run this command. Okay, pip install matplotlib. Okay, and then do this, and then you'll be able to install it. Right now I already have it, that's why it is saying requirement satisfied. Now I'll import the plotting functions in matplotlib as plt. Okay, matplotlib.pyplot as plt. So instead of writing this entire name, I would only write plt. Okay, so that would make my life much easier. Okay, the first and foremost thing that I'll the plot that we will be doing is scatter plot. Okay, now what are scatter plots? Okay, yeah, so basically here in this scatter plot, what we will get to know is if we are mapping it between two data points. Okay, here we are trying to map it between total bilirubin and direct bilirubin, and trying to analyze what is the effect of these two variables against each other. Okay, as we can see that we have done this scatter plot. Okay, plot dot scatter, where we are using two variables. One is total bilirubin and the other thing is direct bilirubin. Where are we getting this from? From our database, from our data set. Okay, this is let's look at it, right? Total bilirubin and direct bilirubin. These are the first two data points that we have, and we are trying to make a scatter plot out of it to analyze what is the interaction, or what is the what is the interaction between these two particular variables. Okay, as we can see that there are some outliers in the process. So here there is a data point. So here everything is going smooth, it's growing exponentially. I mean, it's like a linear regression where as x-axis is increasing, the y-axis is also increasing. However, there are some minor data points which are off the grid or off the track. Okay, this data points and this data points. So this basically tells us, okay, if there are some anomalies or if there are some outliers, which is very much away from the standard standard plots, right? If there are very different from this, then you will be able to understand from a scatter plot. As we can see, there is this one outlier here, and there are two outliers which are very much off the grid of the standard pattern. This is the standard pattern that we can see between these two variables, that is total bilirubin and direct bilirubin. Okay, we can say that they are very correlated. They are highly correlated because that's what the general pattern says, right? Most of the data points are following in this particular track, except for these minor points. Okay, so after knowing this information, what we can do is we can treat these outliers, or we can remove these outliers, or there are different ways of treating it. But this is one of the things that basically this analysis will help us in in understanding how to prepare our data, or how to pre-process our data in the process. Okay, so this is one of the observation that we can make, and we can carry forward with either diagnosis, or we can let it be if we think that this is not really affecting much. Okay, but we will talk more about data pre-processing and data preparation and other things in the next set of sessions. But that's some context. Here we were able to observe something. That is, one thing is they are highly correlated. Okay, and the other thing is there are some outliers. Okay, so similarly, you can do some there is something called as histogram. Okay, so you can also plot histograms, which are used to summarize discrete or continuous data. Okay, it gives you a nice visual interpretation of what is the magnitude of each of your data points across. So basically here we are trying to create a histogram for this particular variable called as age. Okay, and we are able to get individual counts of age in a histogram. Say here we can see that the maximum age, the maximum number of people are falling in this particular bracket. Probably it's between 30 to 40. That's where maximum amount of people are there in your data set. Okay, and again there are the second highest would be in this particular range, that is 50 to 60. Okay, and so on. So you'll be able to understand different dynamics of your data set by looking at histogram. And also there is something called as normalization, standardization, skewness, and bunch of other terminologies, which we will be knowing in the next few sessions, or in the next few learning modules, which will also help you in building your model. Okay, definitely these are some of the data points that we need to capture, and then put those things into perspective while building models. Okay, so here we can say that technically, after looking at this data, this particular thing, I can say that the data is normally distributed. Okay, so which doesn't have any skewness. Okay, when I say skewness, I mean something like this, right? Skewed. When we talk about skewness, right, this is what we mean, where the data is completely distributed on either ends, either on the right hand side or on the left hand side. Okay, so here it is mostly distributed on the right hand side. Here it is mostly distributed, most of the data points are on the left hand side. So this is nothing but skewness. Whereas here in our case, in our particular case, it's properly distributed. It's not normally distributed. So there is nothing, so we don't really need to treat it much. Okay, but yeah, we will get to know more about it in the later sessions, and how exactly we will be using this information in terms of building our models, or in terms of pre-processing our data. Okay, and the third type of plot is the box plot. Okay, coming to box plots, right? Basically, it is used to summarize a set of data, and it often gives you in four. So basically, it tells you how the data is distributed. Even here, you can try and understand if there are any anomalies, or if there are any outliers in the data set in that particular let's say variable. You'll be able to understand it very well by using this box plots. Okay, so in order to get a box plot, what you need to do is you need to Here we have used Seaborn library. So I'm just directly importing that, import Seaborn as SNS. Okay, similar to Matplotlib, there is something called a Seaborn as well. So I'm just trying to use that sns.boxplot data.age. Here I'm trying to create a box plot for the variable age. Okay, so when I do it, I'll be able to get this box plot. Okay, here I can see that it's pretty much normal, and there are no outliers. Okay, however, if I see, let's say if I do it for some other, let's do it for some other data point, bilirubin, total bilirubin or something. Just get the data points. Sorry. So I'll just we'll try and see how is it total bilirubin. Okay, as you can see, here data is there are, it is beyond this distribution, so you can infer something out of this. Okay, so yeah, so these are certain things that we can see in the process, and we can technically if it is off the grid, we can say that these are probably outliers, or we can write down some observation which can help us in the data pre-processing steps. Okay, however, here age is pretty well distributed, as I can see. Okay, there is nothing, there is no difference. I mean, there is nothing that we could do about it, and we can infer that mean age is around 45, and most patients age lies between 35 to 60, that is in between this. Whereas coming to the other thing, while most of the total bilirubin is between this, there are a lot of extreme points which are beyond the reach of this particular range. That is, they are in between 7 to 70. Okay, so which is way beyond. But yeah, that's some inference that you can write again. Okay, as you can see, I think the next thing is total bilirubin. We can observe that there are some outliers in total bilirubin. That's the inference that we can write. Okay, so these all are outliers. So either you treat those outliers by diagnosing it, either by removing it, or there are different ways of treating outliers, which we'll get to know in the next set of sessions. I mean, I don't want to overwhelm at this point in time, but yeah, that's some context. So you try to this is some very basic data analysis, I would say, data analysis or exploratory data analysis you can call, which we will perform before building any models. Okay, so yeah, with that, I think I was able to cover which I wanted to, and yeah, if there are any questions, I'll be happy to pick.
Yeah, thank you, Chanukya, for the great session. I think a very nice basic introduction to all the important things and all the important concepts that initially we had set to be as the prerequisites were covered. So we also have some questions. Yeah, so one was actually a personal question. Sir, as a data scientist, for searching for data set, can we use R language? And for implementing a model, can we use Python? Because in R only, I have heard data mining as possible.
Okay. Yeah, I mean, so there is a big this thing debate about R, which is better, R or Python. Okay. So I think, as I said, data science is not about a particular framework or a programming language. You can technically use anything which of your choice, any open source libraries or any open source frameworks that can help you to scale and use data meaningfully to be able to solve problems, right? So it's all about solving problems in a by using data in a scientific way. So I wouldn't really say that, okay, this is the recommended language or this is the recommended framework. If needed, now, if you have to invent something new, some new tool, you will have to do that. Okay, you have to be extremely innovative in terms of doing that. So yeah, there is no fixed answer for this, if you ask me. Yeah.
Yeah.
But yeah, there are some cases where you'll have, I mean, like, for example, there are some cases where Python will have advantage over R, and there are some cases where R will have advantage over Python. So definitely that's there. Yeah.
Yeah. There's another personal question. How can someone who's already a senior software engineer switch his or her career path to ML?
Okay. That's a good question again. So it totally depends on, like, either one of the easiest thing is to, if your organization is big enough and it allows you to work on some pet projects, probably, like, you can technically work on some pet projects on machine learning, on data science, and do an internal switch. That's the easiest. I would suggest key, I mean, coming to data science and machine learning, right? I think, like, everyone must have heard of this thing. AI is the new electricity and data is the new oil. This is pretty trending for a while. So AI, machine learning, all these things, they are going to coexist in each and every field. So I would rather complement your software engineering skills with data science or machine learning, and then probably use it in the applications that you would be building, rather than switching to machine learning or data science completely. Probably, like, the preference should be given in such a way that, like, you can complement your existing software engineering skills with data science or machine learning. So that is one way. So there is one approach where you can do an internal switch, and the other thing is you can complement and then grow as you go along. Also, there are other ways where, like, some people do masters and, like, or PhD and then gradually switch into the field. That is also there, but I think the first way, where if you can do some internal switch, that is the best option, I guess, because the company already knows your potential and a bunch of other things, and they should be able to absorb you when you bring in additional skill set. Yeah.
Yeah. Okay, so what is the best accuracy we can achieve using ML model, like up to 98%?
Okay, so accuracy, so it depends. I mean, we haven't covered the model evaluation metrics in this session. So accuracy is one of the evaluation metrics that we use for machine learning models. Okay, similarly, there are a bunch of other things. So yeah, addressing your question, sometimes accuracy is not a good metric at all. I mean, if I'm talking about some imbalanced data sets, right? When I say imbalanced data sets, let's say, um, like, there are 100 transactions. Okay, 100 credit card transactions. In 100 credit card transactions, 99 of the credit card transactions are non-fraudulent, and one credit card transaction is fraudulent. Okay, so in this case, when I look at the count of different classes, non-fraudulent is 99 and fraudulent is 1. In such a case, if I keep accuracy as a metric, then I think, like, every time, whenever, like, even if I create a model that says that every transaction is not fraudulent, I would end up getting 99% as accuracy, which is not a great metric, right? So yeah, probably, like, yeah, you'll be learning more about this in the next set of sessions. But when I create a model, let's say, like, in this typical example of 100 data points, where 99 data points are non-fraudulent and one data point is fraudulent. Okay, let's imagine I built a model which says for any transaction, it throws that, like, that particular transaction is non-fraudulent. That means that, like, even if I classify fraudulent transaction as not fraudulent, the accuracy will still remain 99%. So it's utterly useless in that case. So it's very subjective, I would say. I mean, accuracy is not the only thing. Sometimes it's very case specific, and it depends on the problem statement and also objective of the problem. Sometimes we end up using something called as F1 score, AUC curve, and sometimes we also end up using algorithms that provide that may not provide very great accuracy or very great evaluation metrics too, so that we can compensate for the computational costs. So let's say, like, if using a particular algorithm would help me give a reaction time of, let's say, half a second, over using some other efficient algorithm which would deliver the result in 5 seconds, then I would end up using the slightly lesser efficient algorithm which gives the result in 0.5 seconds, because At the end of the day, a user who is using your application may not wait for 5 seconds to receive a result or to receive a reaction, right, on your application. So it also depends on optimization, on the reaction, and also delivery time and bunch of other things. So yeah,
Yeah,
but yeah, I
that
hope
is
I was
true.
able to
Yeah,
address.
yeah,
But
completely. Also, can you please go through where people can find the bootcamp's material? I think a lot of people are confused about where to
yeah,
access it.
so what you need to do is you just need to go to DPhi and go to boot camps. Okay. Basically, if you already have an account, just log into your account. That's the easiest. Okay, and then afterwards you will have this option to go to bootcamp. Okay, this is the place where you can find all the material. Okay, here you can see module 0 kickoff event presentations, and if you want to go through the Python fundamentals, you can go through these courses. Everything is free for use, and you can make most of it. And coming to module 0, you can see that we have already put up some material, and yeah, so we also have some tutorials as well, and this is the live session which is happening right now. Okay, this is
Yeah.
how you can access the material, and we'll also be putting a assignment section where you will find all the assignments.
Yes, and also like to add that we'll be uploading all the today's content, including the PPT as well as the collab notebook,
Yeah,
here itself.
yeah, right, yeah, we will put somewhere here. Yeah.
Yeah. Also, people were asking if how will the next day's material will be available? Will it be available right after they complete it, today's material?
So we
Or
will put it up. So we will put up all the material at a particular time every day. So we will probably release it in the morning hours. That is around uh, 10 CET or probably 1:30 p.m. IST. Okay. By then the materials will be released. We'll try and ensure that we release it much earlier. Okay. And you'll be able to access it irrespective of whether you have completed the earlier material or not. Okay, we'll put it up on day-to-day basis.
yeah. And also about the assignments and quizzes, people were asking how will they get to know about them and where should they submit it?
So assignments and quizzes, right? Again, you will find it on the same platform here. Okay, you will be given some assignments and a bunch of other things, and you'll have to submit it here. Okay, and coming to datathons, right? So in the assignments, we will also conduct some datathons, which are data science challenges. Okay, something of this sort. Okay, where you will have to upload the notebooks, and you will also see a real-time leaderboard as well. Okay, this is how you can see. And just to give you some more context, this is one of the, probably I'll show you one of our previous assignments. As you can see here, these are some of the assignments which were solved by our previous learners of the bootcamp. Okay, so here you can see the leaderboard. Okay, and all the people who are submitting it and all. Okay, so this is where you will be submitting your assignments, your datathon assignments. The quizzes will happen here itself. Everything will happen on the platform. Okay, yeah.
Yeah. And also about the session schedule, we already have it up on the
Yeah,
Discuss platform.
yeah, we
I'll
have already.
also probably add the link to the session schedule to the module
Yeah,
0 or
yeah,
somewhere on the platform itself.
yeah,
Yeah.
yeah,
I think that is all with the doubts. Thank you
yeah,
so much, Chanukya, for such an insightful session and for handling all the doubts. I
yeah.
think we had a great learning time today.
Thanks a lot. I think thanks a lot to other folks on the moderation as well. Thanks to you, Jay, and a bunch of other folks. I think Asha and few other people were helping on the YouTube moderation too. Thanks a lot, everyone, and thanks to all the amazing audience for making it. Yeah, we will be probably conducting few more sessions, and I would strongly recommend, don't get demotivated if you're getting stuck somewhere. Just feel free to use the Slack channels or the discussion forum efficiently, so that you can get your questions addressed. Okay, so there are some really good coaches who will be able to address your questions. Okay, for sure. So feel free to use the discussion forums effectively. That's the advice that I would give. And yeah, with that, I'll take a leave, and thanks a lot for joining in. Take care.